What's going on, everybody? Mr. Diamond here. I'm gonna go shut my door real quick. And we're gonna be working out the example problems for radioactive questions, basically. My first example is a half-life question. My second example is a decay question for beta decay, which is a little bit more complex than alpha decay, so I wanted to actually explain it a little bit more clearly. So we're going to start with the first one. Mercury-210 has a half-life of 10 minutes. So the way this usually gets written is T 1/2, or 1/2 of the time, or the time it takes for 1/2 to go away. It's 10 minutes. And you want to have a sample that has an initial of 350 grams. So we're going to say 350 grams at start. And you ended with 10.94 grams. How much time has passed? So what I like to do is I like to take because the problems are not going to be more complicated than this. There is an equation that you actually will use in some classes about this stuff, but that's more of a math thing than we care about right now. The simplest version of this is just going to be, well, it's got to be in half-lives. So we're going to start with our 350, and we're just going to divide that by 2. So I've got 350 divided by 2. I'm going to plug that in my calculator. I get 175. And then I'm going to divide that by 2. I got 87.5. And I'm going to keep doing that until I get one of them that looks really close to my number. In this case, 10.94, 10.9375, that would round up to 10.94. And now we're just going to count how many times we had to cut it in half. So this was 1, 2, 3, 4, 5 half-lives. 5 times our half-life is 10 minutes. It's 50 minutes. So that's an example of what the work would look like for one of the problems like this. You basically just take this and you're going to keep dividing it over and over again. There are a couple more complex versions of these problems, but this gives you an idea of how you're supposed to solve them. Now our second example is carbon-12 goes through beta decay accompanied by gamma emission. So we're going to start. We need to figure out, well, it's carbon. So we've got our C for carbon. Atomic number for carbon, looking on my periodic table, is 6. So it's going to have a 6 on bottom and a 12 on top. And then it's going to go through, so we're going to put our arrow. Beta decay. Symbol for beta decay is a little b, a 0, and a -1, plus our gamma emission. So the symbol for gamma emission is this kind of curvy Y shape, and that has a 0, 0 value. And then it's got to make something else, but when you're making the last piece, all you have to do is, just like we did with the alpha decay, you have to make sure that the numbers on top and the numbers on bottom add up to the same thing on each side. So on top, we've got 12, 0 plus 0. What number do I have to add to 0 to get 12? Well, I've got to add 12 to that. This side is 6. I have 0 and -1. What number do I have to add to -1 to get 6? Well, I would need 7. 7 plus -1 is 6. Then I'm just going to go back to my periodic table. Number 7 is nitrogen. So my new element is nitrogen. All right, I know that video wasn't very long. If you had to do a chain of this, you would just take, like if it said by gamma emission, then and it said like alpha emission, beta emission, whatever, or alpha decay, beta decay, you would just take this and you would plug it into the next problem that you were working on, this whole piece right here. And you would just use this in the next one, and then take that, use that in the next one, however many times I asked you to do these steps. Well, that's all I got for this video. It's a pretty straightforward process. Like I kind of said in the notes, I assume that most people are really worried when they're like, oh God, we're going to be doing radioactive stuff. But the equations without calculating energy or anything like that is pretty straightforward. So if you have any questions, please go ahead and send me an email. Otherwise, this is Mr. Diamond signing off. I hope to see you or hear from you soon.